Now, let's look a little bit on the agenda. First of all, I would like to mention that we structured the agenda in 8 main topics. First, we were going to talk about the traditional underwriting failures and what are the gaps in the current AI. What is agentic AI beyond automation, and how we can help together with the solution that we are having at SAS Dynamic Actuarial Modeling. Then, looking from a business perspective, we were going to talk about the gray zones of risk reductions, because we know that in underwriting, that zone is actually quite important. What is the architecture that we use for the agentic AI, and what are the impacts? And let's not forget, at the end, the governance, the compliance, and what are the results throughout the demo. Now, looking a little bit on the traditional underwriting, we see 3 main problems. First of all are the static models that we see that industry is actually using for a long time. It's, let's say, training, deploying, but actually forgetting. And the data, actually, it's really important, and we should not treat it like a museum piece, right? That's the moment that we need to understand better how to deploy the model and how to adapt according to different business let's say, impacts that we have in the market, like inflation, new vehicle safety tax, or any other changing patterns. Now, another one that I would like to highlight in here are the slow decisions that most of the time are actually the biggest impact in the market, because you cannot take, let's say, 1 hour or more in order to get a result for your customer. You need to be fast and almost in real time. And of course, it is also the siloed part. We have a lot of silos in most of the insurance companies working on the data part, working on the modeling part, working on the underwriting part, however, not connected, and that's actually taking the process way longer, and it's actually generating a lot of massive operational friction. Now, looking a little bit on the gaps on the current AI-powered underwriting, of course, whenever we are thinking at AI, we may say like, yes, but we are already using AI, right? Most of the insurance customers, they already started exploring, they already started going on the AI journey, and I must say that you are right, you are using it for some of the topics. However, what are the implications, and what are the current gaps that you may have? And if we look on the left side, on the operational gaps, I would say that AI currently is using the adaptability. You need to shift on different conditions. You need to be faster. You need to be to adapt. And with the current AI, you may not have that easier shift without using the agentic part, right? Now, as well, we are looking also on the black box decisions. Sometimes with AI, we get immediately the result of the decision. However, we need to look a little bit more on understanding why is happening like that, how we can prove it to the regulators, what are the processes behind, and how we can generate all of that. And as well, the feedback loop, right? Most of the time you take a decision, however, the system does not learn. It just stops there, and next time it takes, again, a similar decision based on the same pattern. On the right side, whenever we think about strategic gaps, we need to be aware of the portfolio. We need to have also much more dynamic rules embedded, and as well, treating as well the gray zone in underwriting. And I'm going to come in a second on that topic immediately, but these gaps, it's actually the ones that we presented in here, are actually showing you what is the point of moving forward with agentic AI, right? So let's have a look a little bit, how does it look in practice, right? When we talk about this gap, we think about agentic AI as being kind of the bridge of automation beyond AI, right? Kind of an automation 2.0. That actually AI, agentic AI, it's actually a digital co-worker for you. It's actually the shift from a system directly to the processes that thinks, decides, and improves continuously. It does not stop, okay? So first, agentic AI is using different tools, right? So it takes all the data, it looks into it, it analyzes it. It works like a seasoned underwriter, right? that knows exactly what to trigger, when to trigger, what are the business rules, and of course, focusing on regulatory guardrails that we need to embed in the process. Then, also, it sees the portfolio and it can explain it, right? And as well, it can learn fast in order to move forward in the industry. So like that, every system that is using it, it's actually having faster decision, and it doesn't wait for a retraining period of longer, like months, 6 months, 1 year or so, like the generic ones are having that. So let's have a look a little bit how this is happening in our solution, right? In the previous day, on Monday, we had an insurance customer connect where we were presenting some use cases for the solution that we call dynamic actuarial modeling. If you go on our website, you're going to find some information there. If you want to have much more insights about the solution, you can always visit us at the booth and then we can talk about it. But dynamic actuarial modeling, it's actually the insurance AI modeling and decisioning solution tailored specifically for you. It resides on the SaaS Viya, and it's actually having on top of it dedicated insurance content that can help you in order to boost your modeling and decisioning. But more about that, as I said to you, at a later stage. Now, how do we use the solution from that angle? First of all, we use the modeling piece, which is called the Model Studio, where we actually can build any kind of model. We can also grab off-the-shelf models of the solutions. We get the score of the risk, and then we go in the decisioning part, where we have pre-built decisioning rules, or you can build your own, apply your own rules, and at the end we deploy it together in order to have the best model and the decision history. Now, understanding a little bit the gray zones, right? In general, in underwriting, we cannot say that it's a green box, the one on left, it's an easy yes, we accept the customers and we move forward. And we cannot say easily for all the others that are completely on the right as a no. There are also some middle cases that we need to look correctly on them, and we need to address them according to their facets. Now, whenever we look on the gray zones, as you can see in here, we may have several scenarios. Like, for example, the near to the lines, where, for example, you may have the risk 1%, for example, or more, like 1-2% above or beyond the line. So what does it mean? Normally, the traditional systems are quite rigid, and they would take the decision to either decline or approve that policy, right? Or, for example, another one, it's actually one with mixed signals, where, for example, you have some contradictions between the risk. You may have, for example, a perfect driver of 20 years old, but actually, because driving a very high-performance vehicle, it is considered as a high risk, right? So then, how do you treat it? Would you accept it, or would you deny it, you see? So we need to assess as well. Or we may have some missing pieces, right? Like, for example, we may have no data, or we may have little data in order to allow us to take the good decision, and what we do in that moment. And as well, we may have good customers that they are long time in your portfolios. However, because there are certain elements, they might become risky. So how do you treat them? How do you look for those customers? What are the final decisions, right? So these are the typical areas that we want to tackle. So how Agentic AI sort out the gray zones? Because these are the ones that we want to focus, right? It's not like the green one or the red ones that are quite clear throughout the business rules. They will be automatically taken the decisions. But for example, whenever we really look on the gray zones, we start initially with the data, right? We call the data, we get all the information for the variables that we are getting. And in this case, for example, we see that we get a pure premium immediately calculated of being of 5,000, let's say. Under a traditional system, this is just a number, right? But for the agent, this is an attention point, okay? Now, I have to apply some rules. And the agent will apply the rules, the business rules, saying that this is actually an attention policy because it's above my threshold, in this case 5,000, right? And you need to take some actions. Normally, it will be a decline for the business rules that I have set up, right? However, whenever we are looking through the agentic AI, the agent is actually keep going in order to find out additional information to see really like, do I need to decline that policy or do I need to continue with it? So it's looking now on the boundary proximity in order to understand, for example, what are the boundary proximity checks, and it recognizes that it's around only 3% above the threshold that he has set up throughout another business rules. So because it's almost close to the lines, the agent is actually triggering another deep dive in another business rules, and these are the loyalties and the tenures that actually is having with the customer. And we see now with this customer that we have a 7 years tenure, we have 3 policies and 0 claims. So it looks a good customer, you see? So having said all of that, the final rationale is actually to get an approval for this customer and basically to overload them for some of the risk that we could see and then accept the policy, right? But from the first part, it will be complete decline, you see? So this is how this is an example how we treat it. And what we are using in here is actually the agentic AI framework that we are using in order to input all the data, for example, with the Atom supervisor, where we are getting, for example, all the age, all the information about the vehicle, and so on and so forth. Then we go in the orchestration layer, where basically the intelligence shifts gears. There we have, for example, the motor underwriting supervisor that acts as a conductor in order to decide exactly which specialist agent will go further down in order to cover specific needs. And this is actually a full dynamic flow, depending on the customer that we are analyzing, depending on the gray zone that we are analyzing. And here we see that we have multiple specialist agents that are completely focused, some of them on the GLM scoring in order to have all the heavy math calculated, some of them on the underwriting decision in order to look really on the business rules and to apply them. And we also have the recalibration agent, the one that actually continuously have the feedback loop, and it improves all the model throughout the data is triggering additional hits. Last but not least, we have the tool integration that basically connects all of that throughout the ID rules that you could see also. When I'm talking about ID, I'm talking about intelligent decisioning that you probably heard so much these days. And it's actually registering it as an MCP endpoint, allowing the agent in order to pick and use the right tool at the right job. The output is actually, of course, the report that we are getting, and also as well fully documented, so like that you can use it further down for your decisions internally to be justified and externally, right? So this is actually the architecture that we are having. And let me go now a little bit on the impact of the business and the strategic decision. As you can see in here, we have projected actually 5 to 10% gray zone resolution. We have projected as well improvement of the profitability by recalibrating in the real time the models and addressing the market impact. So like that, you are addressing also the loss ratio. On top of that, all the decisions are happening in less than seconds. And as well, we are having a full rationale coverage where we are generating what is the decision result and why we took this result. Now, I would like to mention that last step that we have addressed in here, it's actually the whole enterprise governance. Because this is the final piece of the puzzle that actually ensures that our agentic AI, it's actually disciplined and it's a high performer underwriter. Because we cannot work without the governance, right? And of course, we are focusing here on all the pillars of the governance whenever we think about justifications, regulations, and so on and so forth. But conscious of time, I would like to go through the demo, and I would like to play it from our peer in India, Gajanan, that will explain all the process.
Hello everyone, I am Gajanan Deshmukh. Over next few minutes, I will walk you through the demonstration of how agentic AI system can be used for intelligent underwriting using SAS dynamic actuarial model. One has already set the context and mentioned about the gaps in current underwriting system, and she also emphasized how agentic AI can be game changer when we are talking about the gray zone risk and decisions around it. Before I show you any risk assessment, let me talk about the architecture of this particular agentic AI. So it has 7 different steps, 3 specialist agents, and 1 supervisor agent, 7 different tools, and we are using 4 different wire services. There is one feedback loop. That means system gets better with every decision it takes. Let me walk you through each step. Step 1 is just the step where human intervention is there. We have to open the user interface, select the underwriting task, and then just type the risk in plain English, whether it's a structured format or conversational or just few keywords. So no forms and no fields, just a simple basic text that we have to input here. In step 2, AutomAI server reads the message and routes it to the right supervisor. Here we have one config file, one task, and one supervisor assigned. Step 3 is the step where the intelligence begins. The LLM starts reasoning, and Azure AI reads the prompt, makes a plan. It asks question like whether it's a new risk to underwrite or a request to retrain the model. We have 2 completely different workflows. That is, one is for baseline scoring, other is for recalibration. Then the supervisor decides which agent should be in action and what will be the sequence for those agents. In step 4, 3 different agents will be in action: agent 1, agent 2, and agent 3. The agent 1 runs GLM model and it extracts all 16 variables from whatever the risk we have typed, that is risk in context. We can call it as an actuarial agent. It returns with 2 premiums: one baseline from the original data or the original model, and second is the recalibrated premium from the model which we have trained on the basis of real time decisions. Both come back side by side. Agent 2 runs the decisions. It takes the premium and fires it through the SAS intelligent decisioning, that is a rule engine. It gives a result like auto accept, accept with loading, accept with discount, then refer, or a hard decline. It checks the boundary conditions, generate reports, particularly the audit reports and underwriting reports, and it also takes care of the repository for decisions. Agent 3 is a recalibration agent which is part of the feedback loop, and it will help in triggering the GLM model for the recalibration. We have 7 different tools to support these 3 agents. Each tool is linked with an agent. These first two tools, they are linked to the agent 1. They are basically scoring, baseline calculation of premium, or recalibrated premium that is calculated by these couple of agents. Then we have 4 different tools where they are linked to the agent 2. They are essentially firing the rules and checking the boundary condition and threshold, generating the audit report or underwriting reports, and then logging the decisions. They are writing it back to the CAS. And final tool that is linked with agent 3, and it will trigger the recalibration. So a recalibration can be triggered either by a period or by number of decisions. So period means like you can trigger on monthly basis or a quarterly basis or on annual timeline, or else you can trigger on the basis of decisions like 100 decisions, 500 decisions, or 1000 decisions. So once this particular thing is set, this system will understand from that particular point onward there is need for calculation of recalibration premium, and that will be again calculated with the baseline premium. Step 7 is about different wire services. We have used 4 different wire services: Model Studio for premium calculation, intelligent decisioning for running the rules, then CAS for logging the decisions, and Compute for retraining the GLM model. Finally, when the risk is run through the system, we will get answer. We will get the premiums, baseline premium, recalibrated premium, then decisions around those risk. What is the rationale for taking these decisions? A complete audit trail, all in one block. The tech stack we have considered is SAS Dynamic Actuarial Modeling, Model Studio, Intelligent Decisioning, and the SAS Micro Analytic Core, and the LLM endpoint is Azure GPT 4.1 Mini. All of this is running natively on Wire4, so framework is not considered as a prototype, and we can consider it as an enterprise level. Now very quickly about the modeling. We have used 5000 records with 26 variables and a pure premium model with 2D distribution. We have used a decisioning flow with underwriting engine. This underwriting engine has 13 different rules, and they will set the context related to accept or decline, or accept with discount, or accept with loading. So this is the basic framework related to modeling and the decisioning. Let's now switch to the live system. Here we have this particular chatbot, and we have different tasks. Here you can see our motor underwriting task is there. First we will create a chart session, and then we will choose underwriting task. Here I am going to process 6 basic framework related to modeling. Then we will choose underwriting task. Here I am going to process 6 different risks, and they have, or they supposed to be 6 different outcomes related to underwriting. And let's see like how system handles these particular risks. So firstly we will process the risk for Pele, and we will just try to copy the prompt like this, and we will just write just in a structured format, and we will run this risk through this system. At the back end, a GLM model is run for this particular risk, and decisions are scored in real time. So we have run a risk for Pele, and he has been 10 years with the company. He has 3 policies, not a single claim. So it's a straightforward case, no need of any referral or any thing that we have to consider in underwriting. So it's a auto accept, and that is there. It is accepted with loyalty discount for the tenure of the customer with the company. Now we will process a second risk, and you can notice here that I have used not used the structured format, and I have used a just conversational description for the customer. Very simple. We have got the result for the risk in context. It's a 8 years loyalty, 3 policies, clean record for Maradona, and a loyalty discount fires automatically, that is 10% off. This is a decision that human can take, so it's very straightforward again. But you can notice one thing here. Here is a recalibrated premium. First we have a baseline premium, and now it has a recalibrated premium. So what we have done, we have make a setting that after first risk there should be a recalibration premium. It is just for the demo purpose. It doesn't happen in real world, because we have to have a good amount of experience to get the recalibration. So the feedback loop is working fine, and system is generating the recalibrated premium. Let's process another risk. So you can see I have just used the keywords. So as I mentioned earlier, the input can be in a structured form, input can be in a conversational form, input can be in just keyword form. So it's just a basic simple text that you have to input, and we will run these risks according to these particular inputs. So for Athena, two claims, no claim bonus, high mileage, and new customer. Right? So the system does not decline this risk; it accepts with 15% loading. So it has priced in the extra risk rather than walking away from the business. So it's a accept with loading. Let's try another risk. Let's process this particular risk and see what system gets out of it. Look what we have got for the Messi. So 19-year-old, one claim, no claim bonus, urban area, and high mileage. So that was the description of the risk. So young rule driver fires and a decision is referred because we have set a rule that below 21 years we need to refer the risk. But look at what comes with the referral, a complex explanation. That rule is that is fired. The premium has a boundary proximity, so we can consider it. And and we can mention like this is not a dead end; it is a structured handoff. So we can refer this to the senior underwriter, and we can just consider the two different premiums. Say, for example, uh, 3008 pound and 3032 pounds. So in between this particular spectrum, finally underwriter can write this risk with this particular premium range. So
Oh. What I wanted to close in here, because conscious of time, it took a little bit longer. What is important, as you could see, we don't have a structure of the prompt. You don't have to be obliged in order to have a specific prompt in order to get the decision, and those are the use cases that we wanted to align. And of course, the whole background part and setup of the agentic, according to the structure that Gajanan embedded, it's actually pulling all the results in seconds. And this is key, this is important. Of course, we are looking actually in order to improve it over the time. Feedback is welcome from you as well. But I would like to thank you for now. And of course, if you have questions, you know where to find us. I'm going to be at the financial services booth. I'm also be here for some time. And thank you once more. From me, also from Gajanan and Abshet. Thank you.